Hello and welcome to SQA Higher Maths Vectors. So this is just a continuation from your National 5 vector work. Exercise 5A basically recaps the National 5 vector work along with one other new thing called the unit vector. So let's have a look at what there is to look at. So a lot of these notes you guys can read on your own. But vectors and scalars, a scalar is a quantity with magnitude size only. So for example, you could walk 10 steps. Okay, that only has size, there's no direction involved there. Quantities with magnitude and direction are called vectors. So if I said walk 10 steps north, or walk 10 steps east, or walk 10 steps on a bearing of 037 degrees, that is both a direction and a distance, so that would be a vector. Whereas a scalar is just magnitude only, so walk 10 steps. So that's the difference. So we can name vectors as either AB with an arrow above, or we can use a bold letter, e.g. U, which you'll see in a textbook. But if you will see bold letters used in printed text, but in handwriting you should just underline the letter. Okay, so if you're doing a vector, it should always be underlined. A vector may be represented by its components, so 2, 3 here means 2 to the right and 3 up, and that is the resultant vector there. So we always write our vectors in a column, so we don't confuse them with coordinates. Vectors can also work in 3 dimensions, which we've seen at National 5. We have something called the zero vector here, which your National 5 teacher may or may not have mentioned, or they probably did and you may have forgotten because it's reasonably trivial. But a zero vector is just 0, 0, 0. Magnitude. The magnitude or length of a vector is written as u with a line either side. That's the magnitude of u. And it can be calculated basically by doing Pythagoras. So to find the magnitude of vector u with components a, b, we just do a squared plus b squared, then square root that. And that also works in 3 dimensions, a squared plus b squared plus c squared, all square rooted. So let's have a look here. So given vector u equals 5, negative 12, so that'll be 5 to the right and 12 down. So when we go 5 to the right and 12 down, we do create a right angle. The magnitude of that would be just the distance from the start point to the end point, so going down there. So we just formed a right angle triangle there. So 5 squared plus negative 12 squared. Remember to put your negative 12 in a bracket when you're using your calculators, guys. So that would come out as 169, which square rooted is 13. And we may, of course, have some roots to deal with when doing a question like this. And if we do get an answer of, for example, a square root of 50, as we do here, we should always be looking to simplify that surd. If it's not simplified, we will be losing our last mark. Right, now we're going to have a look at something called a unit vector. This is new. I'm going to do a separate video for this, so this will be in video 1B, because you may have to come back and look up what a unit vector is later on in the course, because it's something we deal with for one lesson, and we don't really come back to it apart from when we're doing an assessment of some sort. So I'll give it a separate video, so you're not having to look all the way through all the different videos to try and locate the unit vector.